What is matter? Matter is something which takes up space and also has some mass. What builds up matter? All matters are built by particles of the same type, which is nothing but atoms, molecules, or ions. That means atoms, molecules, or ions are the building blocks of all the matters existing in this universe. There are four states of matter found in nature, distinguished by their typical physical properties. They are solids, liquids, gases, and plasma. In this picture, we can see all four of them. The fifth state of matter is called the Bose-Einstein condensate. This state of matter does not exist in nature and is man-made. And I will surely give you a concept on Bose-Einstein condensate at the end of this video. Now let me explain the four states of matter. Solids are made of particles. These particles may be ions, molecules, or atoms. Now look at these closely packed particles. Each sphere over here may represent a molecule, atom, or ion and is as a whole represented as solid particles. These particles are bonded together by a force of attraction which keeps them together, and due to this force, solids have definite shape and volume. They are arranged in order. Each particle has a fixed position with respect to the other particles in the solid. These particles do have a slight vibrating motion about a mean position. Due to this very slight motion, solid particles have the least kinetic energy among all the states of matter. Therefore, one can say that solid is rigid. The shape of a solid which is rigid cannot be changed easily. This means that it is difficult to change the position of a solid particle with respect to the other solid particles in the solid. To change the shape of a solid, we have to apply a good amount of force. Or in other words, solids are substances which can withstand at least some amount of shearing force. Excessive force may even cause to break the solid matter. Also, one point should be noted in this context, that solids do break and also can be cut into pieces. The inability of changing position of a solid particle restricts the possibility of two separated solid particles due to cleavage to reunite. When we speak of volume, we can say that a solid volume cannot be changed by applying pressure. That is, solids are incompressible. In liquid matter, particles may be atoms, molecules, or ions, but the particles are loosely packed and more mobile than in solids. But they are still arranged in a specific order and has a force of attraction between them, although not as much as solids. That means the particles do not go too far away from each other, so liquids have fixed volume. But liquid particles can slide over one another and change position with respect to the neighboring liquid particles. The reason why liquids have no fixed shape and cannot be cut to pieces. Since liquid particles are more mobile than solids, they possess more kinetic energy. The movement of the particles is random in nature and causes Brownian motion to very small particles when they come in contact with liquid particles. This type of motion was first observed by Robert Brown in 1827 while looking through a microscope the motion of pollen of plant immersed in water. However, liquids are not rigid, so they cannot withstand even the slightest shearing force. One can easily apply pressure and change the shape of a water-filled balloon. The matter which is not rigid is called a fluid, and fluids are substances which can flow and cannot withstand even the slightest shearing force. That is the reason why liquids have no definite shape. They take the shape of the container. However, liquids do not occupy the total container space. Only that part of the container is filled which is equal to the volume of the liquid. The rest of the container is filled with liquid vapor. Suppose somebody is trying to reduce the volume of liquid by applying pressure. Is it possible? Actually, it is very difficult to compress liquid. Why? Because liquid particles are already close together. However, if temperature of the liquid is reduced, the kinetic energy of the liquid particles also reduce because kinetic energy depends on temperature. In this graph, there are two curves. One representing high temperature where more particles possess high kinetic energy, and another representing cold temperature where more particles possess low kinetic energy. As kinetic energy reduces, the particle motion reduces like this. And see that the particle motion is now quite similar to the solid particle motion. That is, they are vibrating about a mean position. Actually, the liquid has changed its state to solid on cooling. In this process, most liquids are compressed to some extent. However, there is an exception. When water is cooled below 4 degrees Celsius, it expands, and this is called anomalous expansion of water. The particles in the liquid have enough space in between them so that they can accommodate solid, liquid, and gas particles in the gaps through a process called diffusion. When some salt is taken and mixed in water by the help of stirring rod, the particles of the salt occupies the space in between the liquid particles. This means the solid particles are no longer closely packed. When a liquid dye is added in water, the dye particle mixes in water similarly. Now the diffusion is faster and the dye mixes in water after some time, even without the help of stirring rod. When we blow in water through a straw, we are actually trying to mix carbon dioxide gas in the water. This is example of diffusion of gas in liquid. Remember that pure distilled water is neutral. That means it is neither acidic nor alkaline. When we blow carbon dioxide in it, the water becomes acidic due to formation of carbonic acid. Gaseous matter is comprised of particles which are atoms or molecules but not ions. The gas particles have lots of space in between them and their movement is even more rapid, causing the same Brownian type motion in tiny dust particles floating in air. And also due to the same reason, the gas particles are not arranged in order. The gas particles move with a greater velocity than liquid particles. They move in straight lines with varying velocities and a random direction and change direction only after collision with another gas particle or the container. So they have greater kinetic energy than liquid particles. Gases are also fluids, just like liquids, and cannot withstand any shearing force, and so gases have no fixed shape. And just like liquids, it takes the shape of the container. The interparticle attraction is less than liquids, so gases have no fixed volume. If gas is introduced in a closed container, it occupies the total space of the container. Unlike solids and liquids, a gas can be compressed. Plasma is matter consisting of ionized gas, or specifically cationized gas, and electrons held together by electrostatic forces at high temperature. The cationized gas is positively charged and electrons are negatively charged, and they neutralize each other, and plasma as a whole is uncharged. Plasma particles possess the highest kinetic energy due to the high temperature. You will be amazed to know that almost 99% of the universe consists the matter which is nothing but plasma. The sun and the stars consist of plasma. The lightning and the aurora borealis is nothing but plasma. Neon lights and fluorescent tubes are also plasma. In fact, when we switch on a fluorescent tube, we are actually effecting a change of state from gas to plasma. Now let us see the summary of what we have learnt in this video up till now. Now let me explain some important questions on this subject. Question number 1. A rubber band changes shape when a slight force is applied. Is this rubber band solid or liquid? Answer is that rubber band is a solid, although its molecules don't seem to be rigid, because the rubber band retains its original shape when the pressure is relieved. Under excessive pressure, the rubber band breaks. Question number 2. Sugar flows from one container to another and takes the shape of container. Is sugar a solid or a liquid? Answer is that sugar contains lots of small solid crystals, and the individual crystals of sugar are not changing their shape. Although the sugar is flowing, sugar is not a fluid because the individual sugar crystals are not deforming. Therefore, sugar is solid and not liquid. Question number 3. A sponge can be compressed easily. Is a sponge a solid? Answer is that we are actually compressing the air present in the minute holes within the sponge, which expels out. So sponge is a solid. Before ending this video, I promised you that I will give you an idea about the fifth state of matter, the Bose-Einstein condensate or BEC. This form of matter was predicted in 1924 by Albert Einstein on the basis of quantum formulations of the Indian physicist Satyendranath Bose. The BEC was created by scientists in 1995 using a combination of lasers and magnets. Eric Cornwell and Carl Weyman, scientists at the Joint Institute of Lab Astrophysics in Boulder, Colorado, cooled a sample of rubidium to within a few degrees of absolute zero. It was not easy to cool a substance to such a low temperature by normal means. Temperature depends on atomic motion. If somehow the motion of these atoms could be restricted, then cooling could be effected. For this purpose, laser beams were charged from all 6 sides. The laser beam acted as a trap, and in the region where laser beams met, the atoms almost came to a stop. But still, some atoms were moving. To drive out the hotter atoms, a magnetic field was utilized. The magnetic field is shown in the form of a basket created by electricity. The hotter atoms go out, leaving behind the really cold atoms. At this extremely low temperature, molecular motion becomes very close to stopping, since there is almost no kinetic energy being transferred from one atom to another. The atoms begin to clump together. There are no longer thousands of separate atoms, just one superatom. A BEC is used to study quantum mechanics on macroscopic level. Light appears to slow down as it passes through a BEC, allowing scientists to study the particle wave paradox. A BEC also has many of the properties of a superfluid, or a fluid that flows without friction, and that of a superconductor, where electrons flow with zero electrical resistance.